In this video, we will learn about EMF, internal resistance of a cell, relation between EMF and terminal voltage. First, let's understand about electrochemical cell. An electrochemical cell is a device which maintains the flow of electricity in a circuit by converting chemical energy into electrical energy. So here we have an example of electrochemical cell which converts chemical energy into electrical energy. Basically, a cell consists of two electrodes of different materials and an electrolyte. So these are the two electrodes. First is made up of copper and another one is made up of zinc, and here we have the solution which is called electrolyte. This figure shows a simple voltaic electric cell, and here we have the symbol of a cell. The electrode at higher potential is called positive terminal and the electrode at lower potential is called negative terminal. So here we have the positive terminal which is at higher potential, and here we have negative terminal which is at lower potential. When a cell is in use, outside the cell, the electric current flows from positive terminal to negative terminal, that is from this terminal to this terminal. Inside the cell, the electric current flows from the negative terminal to the positive terminal, that is from this negative terminal to this positive terminal. Moving ahead, let's understand about EMF. Electromotive force or EMF of a cell is defined as the amount of work done by the cell in moving unit positive charge once around the entire electric circuit, including the electrolyte of the cell. If W work is being done by the cell in moving a charge plus Q once around a circuit including the cell, then the EMF of cell epsilon is equal to work done divided by the charge. The SI unit of EMF is volt, where 1 volt is equal to 1 joule per coulomb, because work has SI unit of joule and charge has SI unit of coulomb. The EMF of a cell may also be defined as the terminal potential between the two electrodes of the cell when no current is being drawn from the cell. That is, when cell is in an open circuit. The EMF of a cell depends only on the nature of the electrode and electrolyte used in the cell and is constant for a given cell irrespective of its dimensions. For example, the EMF of dry cell is 1.5 volt. Here, one point must be noted clearly, that the EMF of a cell is actually a potential difference and not a force. Moving ahead, let's understand internal resistance of a cell. Internal resistance of a cell is the resistance offered by electrolyte and electrodes of given cell for flow of current through it. Internal resistance of a cell is usually denoted by the letter R and its SI unit is ohm. This internal resistance of a cell depends on: first, the nature of electrolyte and electrodes; second, the concentration of electrolyte; third, the distance between the electrodes; fourth, the surface area of the electrodes immersed in electrolyte; and fifth, the temperature. For a given cell, internal resistance is minimum for freshly prepared cell. The internal resistance of a cell goes on increasing as the cell is being used. Now let's understand the terminal potential difference. Terminal potential difference or terminal voltage of a cell is defined as the potential difference between the positive and negative terminals of the cell when cell is in a closed circuit. That is, when some current is being drawn from the cell. Here we have the relationship between EMF and terminal voltage of a cell. Let a cell of EMF epsilon be in a closed circuit supplying a current I, then the potential drop inside the cell Vi is equal to I into R. Hence, terminal voltage V of the cell is given as terminal voltage V is equal to epsilon, that is EMF, minus Vi, which is equal to IR. So let's replace this Vi by IR. So we get V is equal to epsilon minus IR. Here we have the difference between the EMF and terminal voltage of a cell. First is EMF of a cell, and then we have terminal voltage of a cell. EMF of a cell is equal to the amount of work done for moving a unit positive charge once around the complete electric circuit, both outside as well as inside the cell, whereas terminal voltage of a cell is equal to the amount of work done for moving a unit positive charge once around the external circuit of the cell. In EMF, the complete circuit is considered, whereas in terminal voltage, only the external circuit is considered. EMF of a cell is a characteristic of the cell and is constant for a cell, whereas terminal voltage of a cell depends on the current drawn from the cell, that is, higher the current drawn, lesser is the terminal potential difference of the cell. I hope this topic is clear to you. Thank you.